Hi everyone. Any questions? Hi everyone. Any questions from anyone about the project?
So the only question is, sir, we need to consider the load combination for the slab movement, slab load. We need to consider the load combinations, sir, for getting the dead load and live load for the for the slab.
Yeah. So you have the slabs. Yeah.
Yeah. Yes, sir. 1.5, 1.4 DD plus 1.5 live loads. I think I got some from load combination.
Wait. So you have the dead loads.
Yeah.
Dead load means self-weight of the beam.
Self-weight of the slab, sir.
Oh, sorry, slab.
Yeah.
And the tiles and ceilings that's given.
Yeah.
Okay.
Yeah.
So you had dead load of the slab and live load from table 3.1 as a KPA.
Yes, sir.
Then you need to combine them. What is the load combination for bending moment?
So I think 1.4 plus 1.4 dead load plus 1.5 live load, maybe. I forgot. I need to look. Let me check.
It is 1.2 and 1.5.
Is that the 1.5 for 1.2 for the dead load and 1.5 for the live load, sir?
Yeah. So
Okay.
all these ones, you need to put a reference. Okay.
Yes,
so
sir.
you need to put a correct close and the standard. So basically, the
Yes,
submission should have something like I think the solutions for the tutorials given. So when you look at the tutorial solutions, I will upload the week 5. Sorry, my apologies. I will upload that one tomorrow.
Yes, sir.
When you look at this, the tutorial solutions. So
Yes, sir. We designed without the load combination, sir. We didn't consider the load combination, but the moment was so small, sir.
So how did you calculate without load combination?
Sir, just use the dead load plus live load. That's it. No, we haven't used the load combination for that.
That is wrong. Huh?
Yeah. So due to that, so the moment was just 40 Newton, 14 kilonewton, 40 kilonewton, sir.
Yeah, for the slab, you may not get big moments. Normally, slabs are mostly critical with the deflections. Okay.
Sir, not for the slab, sir. We use the dead load plus live load for the calculation for the beams movement, sir. That was just 40 kilonewton, sir.
Yeah, you need to use for everything bending moment, shear force calculation. The load combination should be 1.2 G plus 1.5 Q.
Yeah. Okay, sir.
Okay. So all the bending moment, shear forces. Everything should be calculated. And when you have this, I think it's a two-way slab. So you have, isn't it?
Yes, sir.
So if it is a two-way slab, you need to find out equivalent distribution, because you get the trapezoidal or triangle distribution, isn't it, in the beam?
So we consider the triangle distribution, sir.
Yeah. So in that case, you need to find out bending moments. You need to calculate the equivalent UDL for the triangle. I think it's discussed in week under the load distribution or something like that. There's a formula. What is?
I have a question, sir, in maximum crack spacing equation.
Sorry?
I have a question for the crack spacing equation in crack control for beams. The letter C.
We'll fix this one first. The load estimation, I think I gave something like this one somewhere in the study guide. Equal and load combinations. Yeah. Triangle distribution comes like this. Have you seen these equations before? I think I should have that one. Wait, I think in one of the, yeah, here it is. I think it should be in the week 1 or week 2 lectures. I put the load estimation. I explained this one. So when you have triangle distribution and trapezoidal distribution, you should have equivalent loads. So you should use this one because to draw the bending moment diagram for the beams, you need the uniformly distributed load. You can't use that 6.10 with triangle distribution or trapezoidal distribution. Okay. Is it clear?
Yes, sir.
Yeah, so another one asking about the crack control. Sorry. Who is that?
Yes, sir.
Yeah.
In the letter C, it's the clear cover to the longitudinal reinforcement. So we will consider the shear reinforcement. We need to add that to the clear cover because it's clear cover to the longitudinal reinforcement.
Sorry. I couldn't. So you are talking about slab or beam?
Beam, sir.
Okay, for beams, yeah.
Control. There's a formula 3.4C for maximum crack spacing. 3.4C and.
Wait, in the standard?
Yes, sir.
Okay, give me a second. I will open that one.
8.6.
So what is the 3.?
8.6, sir.
8.6. Yeah.
Yes, crack control.
Yeah, crack control. Yep. Yeah, that's correct.
8.6.
So you are using if it is interior beams. Okay, it is Gerald, isn't it?
Yes, sir.
Okay, so Gerald, so if you have this section, okay, this one, isn't it?
Yes, sir.
So you have 3 possibilities. Okay, the first one is a very simple one. If the beam or slab is inside the building, so that means if you look at that one here, this area for the regions, so the second paragraph, I'm not sure whether you see that one. My mouse, can you see my pointer?
Yes, sir.
Okay, so for the region being fully enclosed within the building, okay. So the crack control can be satisfied with these 2 things. So that minimum reinforcement, you already did that check. Then the spacing cannot exceed 300 mil between 2 bars, and the bars cannot put more than 100 millimeter from the wall of the beam, you know. So okay. If it is, that's okay. But if the beam is exposed to the environment, then you need to go to one of this method. This is indirect method, and this is the direct method.
So in the answer, we don't need to compete for the cracks.
Yeah, but
it's not.
Yeah, but what question you asked? I can. You don't need to do that one if you don't need. But just ask me your question so that I will explain what to do.
The formula for SR max.
This one?
Yes, sir. And there's a formula.
Yeah, that is given. Yeah, it's here. Yeah.
Because the letter C, the clear cover to the longitudinal reinforcement.
Clear
So
cover.
it's the concrete clear cover or the clear cover until to the longitudinal reinforcement.
Longitudinal reinforcement. Yes. So if you have that one, so technically the cover plus the shear reinforcement diameter will add it.
Okay, sir. Thank you.
Okay. Yeah, if you need to calculate, you need to do, but for inside environments, you don't need to do that. Okay, that doesn't mean you don't need to calculate, but if you have any question, you can ask. But what I'm saying is, you don't need to do all the calculation, but generally, if you want to do, say, for example, if your beam is exterior one, okay, I will go with the indirect method first. That's easier one. Okay, so this is the indirect method. So you just need to calculate the stress at the steel in the tension steel under service load. Okay, under service load. So basically, you need to. I think I work out in one of the worked example under study guide. That is much easier rather than calculating all this crack width. Okay. But if your crack width limit is 0.1 millimeter, yes, you need to do it because this table work with the 0.2, 0.3, 0.4 only. So if you want the crack width limited to 0.1 millimeter, then you need to go for this crack width calculation. Okay. Is that clear?
Yes, sir. Thank you.
Any other things? So we have on 11 students. So is anyone from group 1? Anyone from group 2?
Me, sir.
So how is the progress? Are you able to progress? I just want to check in. Don't worry for attendance. I'm not taking attendance. So group 2. So how is your progress? It's have you completed the slab design?
Not yet, sir. I completed the beam design, but I need the slab thickness for the slab. So I already completed for the beam design, like the format for Excel. So I just need.
You completed beam design?
Not totally completed, sir. Just the format in Excel.
Okay.
So the design thickness for the slab. So
yeah, if you use Excel to submit, are you planning to submit the Excel one, or you
no,
want
sir,
to
just for the faster calculation? So I need to retype it first.
Okay, if you plan to submit in Excel, yeah, sometimes some students submit a submission as an Excel file for each one's slab design, so they put a different worksheet. So you can do that, but make sure you have clear explanation in the works Excel. So first column with the references and like that. So please make sure you submit it the correct way. Otherwise,
so we can submit the PDF from the Excel after convert?
If it is Excel one,
yeah,
you can submit a PDF from the Excel, but I need the soft copy because Excel PDF doesn't show any equations. How you get
so we'll put the equation all above, and so we'll just solve the below that.
Yeah, so I understand, but what we'll do is you put the equation.
Yeah.
You will then Excel will give the final answer.
Yeah, sorry.
So sometimes it's very difficult to use check which moment you use and other stuff.
Yeah, sir.
So you can submit as a PDF, okay? But as
Yes,
an
sir.
attachment, you just send submit the Excel as well. So
Yes.
if I have any question, if I have any problems, I will look at that Excel. I will not mark the Excel.
Yeah.
So if I need, I should able to check which M he used. So sometimes it's a little bit difficult. Sometimes how this number comes.
Yes, sir. And sir, and other things are while designing the slab, we need to consider the whole slab load or just the trapezoidal portion, sir.
So your question, you have a slab, okay?
Yeah.
So the whole slab should say, if it is a level 2, I think
Yeah.
you are designing
Yeah,
level 2.
level 2, sir. Same.
So first you need to assume a depth.
Yeah.
So
We have
for
assumed that, sir. Yeah, sir.
which
150.
okay, so then you need to check for deflection.
Yeah.
Where you will check the deflection?
We did in the Excel, sir, but I don't have a current Excel like Excel file.
No. So you have about how many squares? I think 12 or 9. How many panels you have? Wait. How many panels you have in the slab?
Need to design for the whole slab for the label or just a one?
Wait.
We have 12 panels, sir.
Yeah, so we have 12 panels. So this is the slab.
Yeah, so yeah.
So you need to design this whole slab. But that
Okay.
doesn't mean you need to do each and everything.
Yeah.
That's what we discussed today. So we have 12 panels. This one, each one called panels.
Yeah.
Okay. Each one called panel. So this is a two-way slab. So you have 12 panels. So the whole slab should have same thickness. You can't
Yeah,
have
sir.
each panel different things. Yeah.
So
So-
sir, just for sir, we are the group 3, so we need to use the 3.8 lanes. We need to design the whole using the 3.8, sir, in X direction.
Yeah, that's what I'm explaining.
Okay.
Okay, give me a second. So you have 3.8, 3.8. So the whole length is about 12 meter, less than 12 meter, a little bit. Yeah. So
Yeah.
no, sorry, less than 16 meter. Yeah. So you have 3.8. Okay. So you need to technically design this one, but that doesn't mean you need to do each and every panel. So you have 12 panels. So the whole slab should have same thickness. You can't have this one 150, this is 200, this is 175, like that. You can't have different thickness, isn't it?
Yes, sir.
So in that case, you should have same thickness for the whole slab. Then how I make sure my thickness is okay? So to check my thickness, I will use deflection. Yeah. So deflection of one of the panel. Each panel will have different deflections because each one have a little bit different in continuity, because this panel have continue this side and this side, but nothing here and here. Yeah. So this corner panel doesn't have any slab in both sides, but continue only two sides. So like that, each panels have different conditions. Each panels have different conditions. So that means each panel may have different deflection. So to check my deflection is okay or not, I need to find out the critical or maximum deflection. So now the question is, which panel will give larger deflection? Which panel will give the larger deflection? So if you look at that one, the deflection check is under section this one. Select it, yeah. Isn't it? So you have the equation, this one. So K3, K4, this is for one-way slab and the flat slab. Okay, flat slab is a level 1. So this is one-way slab and flat slabs. Flat slabs are in level 1. We are not talking that one. We are talking about two-way slabs. So this is the closed rectangular slab supported on 4 sides. So this is the two-way slabs. For two-way slab, they said K3 should be 1, K4 should be taken from here. For K4 value, you know LX and LY. Everyone have the LX and LY. Yeah, I discussed this one, how to get LX and LY. LY is the largest effective span. LX is the shortest effective span for a particular panel. Okay, I'm talking about panels, not the whole slab. So LX and LYs are the longest and shortest effective spans. So you know that dimensions. Effective span is minimum of Ln plus D and L. Okay, so I work out those things in the beams as well. We discuss in the tutorials. So we have different conditions. As I told, each slab will have different conditions. So this one, so this is 3.8 and 4.2. So the longest, the two edges are discontinuous. Two adjacent edges are discontinuous. So if you look at that one, two adjacent edges are discontinuous, number 6. Number 6. If you look at this one, this is discontinuous. Only one edge is discontinuous, that is 3.8 for the group 3, 3.8. So that is the shortest length because this is longest, 4.2. Okay, this is 4.2 because for some group, this is the longest. So for some group, this is shortest. So this one is the shortest for the group 3 because 3.8. So that is less than 4.2. So for this panel, if you are calculating, shortest edge is discontinuous. One short edge is discontinuous, number 2. So like that, for each panels, you should be able to find out. So for this panel, all 4 sides are continuous. All 4 sides are continuous. So 4 edges are continuous. All 4 edges are continuous. So that is for the interior panel. So like that, you will have different K4 value for each panel. So when you have different K4 value, K3, K4 might be different. So my question is, which panel will give largest deflection? So if this side is constant, if you want to have larger deflection, K4 should be smaller. K4 should be smaller, then only you will get a larger deflection. So look at here, which one have the shortest K4? So if you look at that one, so K4 is shorter here. 4 edges are discontinuous. We don't have any cases like that. We don't have any cases 4 edges are discontinuous. We don't have anything like that. 3 edges discontinuous, also we don't have anything. Okay, if you look at the panel, we don't have any panels with 3 edges are discontinuous. So the last 3 are not applicable in our panels. So okay, let's look at this one. So if you look at this, 2 adjacent edges discontinuous will have lowest K4. Okay, for any ratio, this is so that is the corner panel. So corner panel will give larger deflection. So we need to check your deflection at corner panel. Okay, so you assume the depth of the slab, okay, for the whole things. same. Don't worry about the other panels. Look at the corner panel. So you need to find out whether your assumed depth satisfy the deflection check at the corner panel. If the corner panel satisfied, all other panels will have lower deflection than the corner panel. So that will definitely satisfy. Okay. So is that clear?
Yes, sir.
So in the corner panel, which span I should consider? We had two spans, longer one and shorter one. In this one, which L you will use?
Short
Huh?
span.
Huh?
Short
Shorter
span.
Shorter one, yeah. So we need to use the shorter effective span, that is LX. That use LX here, effective span, and K4 value you have to take from the table, depend on this ratio. If you have something in between these two, do the linear interpolation. Okay, so you should able to check whether your assumed depth is okay or not. Is that clear? So I just want to confirm. So group 2, how is your progress? You said the beam Excel has been completed.
Yes, sir. It's just for like trial and error for the size. But
Yeah, so I think first thing you need to, at least before you start the beams,
yeah,
someone need to do the slab thickness at least before you do all the design. At least confirm the slab thickness, so then you can find out the loads from the slab.
For.
Okay.
Yes,
So do you think that you can finish the things, the slab and beams, if I upload all the things by tomorrow for the slabs, all my week 5 contents will be uploaded in Moodle. So do you think before the break, so next week is a break week? Yeah, no teaching.
yes,
No
sir.
teaching. I'll be here, but it's no teaching. So do you think you will be able to complete up to the slab design and beam design by end of next week?
End of next week, sir. I think so.
End of next week.
Yes, sir.
Okay. So okay, so I will say okay. Yeah. Let's see how that will go. What about anyone in group 3 here?
Yes, sir.
So how is what about your progress? So have you completed slab design?
Not it, sir, but we have done beam. We've got like a very small moment while calculating the beams.
But you don't have slab thickness and others.
Yeah, we consider this, assume the slab thickness 150 mm, and we carry out the beam design. So while calculating the total load on beam, we have to calculate the slab load also and put it on
Yeah, slab load will come there.
Yeah.
That's what I show that one, the trapezoidal or triangle.
Yes, sir, we have done that one, and we put the total slab load as a dead load on the beam.
You need to transfer the dead load on the slab separately, light load on the slab separately.
Yeah.
And find out the equivalent UDL.
So can I share my screen, sir?
Yeah.
Yes, sir. We can we calculate the load like this.
Yeah, this is for is for beam.
Yes, sir. We first calculated the load on the slab, and then for total beam load, we add the slab.
Wait. So if you look at the line 20,
Yes, sir.
You have 4.8 kilopascal
Yes, sir.
self height of the slab.
Yeah.
So what about the other one, tiles and others? So you have that one.
Yes, sir. That one superimposed load. Yeah.
Yeah, you need to add that one, isn't it?
Yeah.
So the dead load on the slab, is equal to self height of the slab plus all the superimposed dead load. Yeah.
Yeah.
So that will be transferred. Okay.
Yes, sir.
Transfer the slab, sorry, dead load separately, live load separately.
Okay.
Okay. Because don't factor, because if you factor, you cannot add the self height of the beam. For the beam design, you get the load from slab,
Yes, sir.
but you also have self height of the beam, which you don't have that one in the slab.
Yes, sir.
So you have the dead load on the slab, which is self height of the slab plus superimposed dead loads.
Mhm.
Yeah.
Yes,
So
sir.
that load will transfer from slab to beam. So that distribution may be triangle or trapezoidal, depending on your dimension. Okay. So if you have trapezoidal or triangle distribution, then you need to find out equal load as you shown in this diagram. Okay. So find out what is the equivalent slab load, slab dead load from slab to beam. So then find out what is the equivalent live load from slab to beam. Okay. Give me a second, 1 minute. Sorry, my apologies. It's a internal call. Sorry, can you share that one? Sorry,
Okay, sure.
my apologies. So you understand you need to transfer the load. Okay.
Yes, sir.
You need to transfer the load. You need to transfer the load. Dead load and live load separately. Yeah.
Yes, sir.
Is that clear?
Yes, sir.
And then once you have the dead load, you need to add the self height of the beam. You need to add the self height of the beam. So you'll have total dead load for the beam and live load. So then you put the factor. Okay.
Yeah, got it, sir. Yeah. Thank you, sir.
Any other question?
No, sir. No. Thank you, sir.
Okay, so that is group 3, isn't it?
Yes, sir.
Group 3, okay. So what about group 4? So you should, do you think next week, you should be able to finish the slab and beam. I'm not asking columns, so slab and beam. At least the level 2 slab and beam. I'm asking. Okay. So Gerald, sorry, I'm not sure. For
Yes,
your the crack control calculation you might need for the roof. Because I think roof limitation is given as a 0.1, isn't it?
rain
Yeah. So you need to calculate the crack width in the roof slab.
Okay. So for the slab level 2, because we know that there are 12 panels, but some
Yeah,
of
so
them.
what we need to do is once you finish the level 2, okay, you don't need to do any more calculation. You just need to take the depth in the reinforcement detail, see where the same depth and same reinforcement can be used for the roof if the crack width is limited with 0.1.
Yes, sir.
Okay.
Yes, got it.
The level 2, you don't have any limitations. It's normal slab. Okay, so for that 300 millimeter spacing or 2D should be enough. So you don't need to calculate the crack width for the level 2. At level 1, you don't need to do any check for deflection. You don't need to check for bending or shear or anything. You only need to check for cracks because the roof slab will have lower load, less load compared to level 1, level 2. Okay, so the roof slab will have lower live load. So the live load is smaller, the total load is smaller. So the crack width is only limitation in the roof slab. So you don't need to redo any of the calculation you did for level 2. Use the same thickness, same reinforcement, and check what is a crack width you will get. If the crack width is not less than 0.1, then you need to increase the steel. That's all you need to do. If the crack width is more, if the crack width is more than 0.1, you need to increase the steel. If the crack width is less than 0.1 millimeter, you don't need to do anything. You can say that same arrangement can be used. Okay, is it clear? For the part C, your task part C, you don't need to do any bending, shear, deflection checks. You only need to do the crack check for the roof. Use the same thickness, same reinforcement arrangement, and calculate the crack width in the roof slab. Again, the corner panel most likely gets a larger deflection. Okay, so use same thickness reinforcement arrangement, calculate the deflection in the roof slab, and check whether the crack width is less than 0.1 or not. If it is less than 0.1, you are done. You don't need to do any further calculation. You just say that same arrangement can be used in the roof. That should be okay. If the crack width is larger than 0.1, you need additional steel. So you need to increase the steel a little bit and see whether you can get it 0.1 or less. Okay. Is it clear? So don't repeat all the calculations. Read the question carefully. If it is not clear, just let me know.
So for level 2 slab, there are 2 panels, but I think we only need to design 4 panels because some of them are like similar
Sorry?
cases. We know that there are 12 panels in level 2 slab, but some of them are like similar slab, like the cases. For example,
Similar
there are,
slab?
yeah.
I could understand similar slab.
For example, there are 4 corners panels. They are all like similar. So we just need to design one of them and like.
No, wait. I couldn't get your question. Maybe, can you repeat? Sorry.
In the framing, sir, in assessment, the framing, the frame plan, there are 12 panels.
Yeah.
For example, the four corner panels, but they are all the same. We can just design one and consider that design for the corner panels.
Oh, so okay. So the design one. Okay, sorry. Yeah, I didn't come that one. I just still in the depth. Is that okay? Clear with the depth? So then, if you want to design the slab panel, sorry, Chirag, I think. Okay, so if you want to design that one, so because we check the deflection at the corner panel only. Okay, so now we will go for the bending moment and design for the longitudinal reinforcement. So again, you don't need to do for the whole things. So you need to look at which panel may get larger bending moment. So most likely the corner panel will get the larger bending moment. So design for the corner panel. Okay, most likely, most of the time you might get similar bending moments in slabs. So you might provide the minimum reinforcement or the reinforcement at 300 millimeter spacing. So you can't reduce further. So technically you can say the whole panel, whole slab will get the same reinforcement details. Okay, so you don't need to repeat that one for each panel. Is that clear? Is that what you asked?
Yes, sir.
Okay. So yeah, just check one. Group 3 is okay. Group 4, anyone? No one from group 4. Okay. Group 5. No. Group 6.
No, sir.
So how is the progress? Are you under control or do you have any problems?
No.
All good?
Yeah.
Group 7. Group 7. Group 8.
Yes, sir. We are starting this project from this week because we have a like project implementation this term. So me and Kalrav are like completing that our final test of our projects of our research project. So we are starting this assignment from this week.
This week means yes, sir.
No, sir. We are starting from like
Wow.
no, sir, not now, sir. From like today or tomorrow, because Kalrav have his highway
This is
complex.
a group 8, isn't it? Group 8,
Yeah,
is
yes, it's a group 8.
it? Okay. So you are doing the implementation now.
Yes, sir. We are having just our test finished. Just 1 or 2 tests left in our implementations. So we are going to finish that, and we are starting this from like this end of this week.
Okay. So have you attended all the, have you look at the lectures recording at least?
Yes, sir. Yes, sir. We are looking at the lecture recordings and also the workshop recordings.
But I don't think we have any workshop recording. Anyway,
I mean, sir, we are attending the workshop, but we are just looking at the lectures also.
okay. Okay, so just try to manage both together. I know that's so you finish all the experiments, things and the implementation are still going.
Sir, it's still going, but we will finish in this week.
So you're doing in Melbourne, isn't it?
Yeah, sir. We are doing in Melbourne.
Geotech.
Sorry, sir.
Geotech test.
Sir, Kalrav has a transportation test for his environmental concrete, and I have a water engineering sewage treatment plant laboratory tests.
Okay. And make sure you don't delay the things because it's not one day work, this one.
Yeah, sir.
Okay, so you need to start group 8. So what about the group 9? 10? So no one, so there are 11 students now. I think it's dropped a little bit. So group 2, 3, 6, 8, that's all. No group 1. If you can't speak, you can put a message in the chat. No one from group 1? You don't know what is a group number? Because there were 11 students, but only 4 groups. How is that happen? Group 2, 3, 6, 8. There's no other groups here.
So we will probably, if we are the group 3, sir, we will probably complete by next week, sir. So that we will consult you for the more details, sir, because we are a little bit more confused as well. So we'll try to figure it out by looking the lectures.
If you have any problem, just let me know. Next week I will
sure,
be
sir.
here. Okay. Just want to confirm. Okay. So because next week probably I will be here. Sometimes sometimes 14th may not be here, but all other days should be okay. But if you need anything, just let me know or send an email. Okay.
We'll send you the mail through Moodle, sir. We'll take you through Moodle, sir.
When you send an email, could you please put your mobile number also? Because sometimes it is easier to give a call and ask or explain rather than sending email. And also if you are working part-time or full-time, prefer time for contact. That's right. Okay, so 5 o'clock or 4 o'clock, whatever. Okay. So just let me know. That's easier because it's sometimes writing emails with all the explanation will take lots of time. Yeah.
So definitely.
Okay, so I probably tomorrow I will update all week 5 contents, and I will try to open the week 6 and 7 as well. Week 6, the column 1 as well, early as possible, so that you should be able to try, but at least try to finish the slab level 2 roof slab beam design. So then you should be able to do the flat slab level 1 and columns after the break. So just make sure before end of next week before, it means about 14th, yeah, 14th of next week. You should finish the level 2 slab, roof slab. Roof slab is not only crack things, and the beam design. Make sure that these 3 at least completed. Otherwise, you will fall behind, and sometimes it's a little bit difficult in the submission. Okay, so please, one thing I can tell, okay, I know everyone have different commitments. Okay, you might have some part-time work and others. Please spend a little bit time. Make sure you submit a good report. Yes, that will help sometimes in case if you slip in the class test. It will help you to get the supplementary. Okay, so don't let it fall through the cracks, and at the end of the day, it's a pass or fail in the, so try to get a good grade rather than spending less time and repeating this unit again. Okay, that's lots of money now, I know. I also came as a student. Okay, so I know all the problems. Please make sure submit. If you have any problem, feel free to contact me. Okay, if you want, just give me a call on my office number, or send me an email with your contact number. I will try to go. Okay, so Monday and Tuesday quite busy because I have classes until 7:30 yesterday, 6 o'clock today, starting morning. Okay, so I'm teaching 3 units, everything back to back. So I have only teaching Monday and Tuesday, but 3 units, so 6 classes, plus other things. So everything comes back to back. So please let me know if you have any problem. Wednesday, Thursday, Fridays might be good. Yeah. So here you came for learning, so try to learn. Okay? If you know the structural design, I'm not sure how many of you are working in the structural company, but structural engineers will get more money. Okay?
Yes, sir.
More money, and at the moment, I'm not sure about Melbourne. Here in Queensland, lots of shortage for structural engineers.
Yes.
One of my undergraduate student, he also overseas student, so he also came. He's an international student. He completed last year, June, and he's good in structures. Before graduation, he got 3 offers. Okay. So you need to know things, because he asked in the interview, they check basic things in structures. Yes. So if it is a structural consultant company, he got 3 offers. One is in Townsville, one is in Rockhampton, and the other one is in Victoria. So I think so. He also international student, so it's not a local Australian student. So he got offer. He's working. He's undergraduate student. So you're postgraduate, so you should have better chance, but you need to know the standards and everything. That's what shortage for structures. Okay, so please make sure if you need anything, just let me know. I'm happy to help, but not after the grade release. Okay, so if you have any problem, ask me. Okay. Okay, I will by code. I will upload this.